Today we are going to learn about object-oriented programming. So what is object-oriented programming? And if you join computer programming, I guess you learn a little bit about this object-oriented programming. I'm going to teach you just briefly so you can have in your mind about what is object-oriented programming, and many algorithms will need this object-oriented programming. So we are going to learn at least three things. First, we are going to learn what is the object-oriented. We are going to learn about the class, constructor, data member, and method. And we are going to learn about the design principles of object that are modularity, abstraction, encapsulation, and inheritance. And we are going to learn some abstract data types. This is the Google Colab. So first, what is object-oriented programming? Or sometimes we call it OOP. First, we need to understand that this OOP is about robustness. The software should handle unexpected inputs properly. So if you have your data as integer, and let's say you want to input string, so your program should handle this kind of input should not be in your program. So your program should handle only integer. Adaptability. It means your software should evolve with the changing conditions. It means when you have a software, when you have an algorithm, if you want to improve or you want to upgrade, the structure might be the same, but maybe you just need to have one more function. You can have one more function to upgrade your algorithm. And reusability. So the code should be reusable across different applications. Once you have your code, you can use in Windows, you can use in Mac, and sometimes you can use your algorithm in your Android phone, and so on. So you need to look at the code that is reusable. The terminology of object. We can see an object later. This kind of object in a program, we call it an instance. Or we call it, this is an instance of a class. So the terminology, we can see here instance, class, and object. So using the word class, it is to define the class name. And then we use the word def to define the method. So for example, this is the class diagram. And then whenever you have a class, here is the class in Python. You have the class name. So this is the class name, and the class name is person. This class name refers to the class name in the class diagram. For the first class, we have a method, or we call sometimes a function. And this function starts with def, and the name is say hi. Okay, so we will take a look what is self later. And inside of this function, we have one statement, which is print. For this one, we have one method and we need to define in the class diagram. The class name is say hi. And then we have a data type. Point. Point means it is a function. No particular data type. There is no particular data set. When you call this method, it will show the print. So there is no specific data set, even though we know that this is a string. So above example shows a class of a person. When we look into the class diagram, in theoretical, we call it, this is a unified modeling language or UML. A class diagram has three portions. The first is the class name. So this is a class diagram. This is also another class diagram. And we have the class name. So the class name is person. And this class diagram also has a name, which is person. And the other portion, we call it the data member. The data member means this is the recommended instance variables. We know if it is a person, then there should be a name. Maybe there is another kind of attribute, we call it age. Or maybe there will be another attribute, for example, city. Or maybe date of birth. And so on. So those kind of things, we call it data member. And we need to specify what are the data type. For example, name, the data type is string. Age, the data type is integer, and so on. Number three, the recommended methods of the class, or sometimes we call it methods. So methods mean something that we will execute. So for example, here we have method get name. And when we call this method, it will return string. Get its, when we call this method, it will return integer. And when we call this method, we need to have two arguments, name and its. And the type of this method is void. So it means there is no particular data type. This is another class diagram. But if you see this one, we have only class name, no data member, and only one method. So this is the variation. So you later on, you can see many other data, many other class diagram. And sometimes we have only one, or sometimes we have only two, and sometimes we need to define a lot of data members. And we need to define a lot of methods, and so on. As I mentioned in the previous slide, we have the object. In this case, we have the person object. So the class definition typically specify the instance variable, also known data members, that object contains, and methods, also known as member function, that the object can execute. So if we look at this code, so we can see the fix to this. For example, the person, it is the person name in this class diagram. In this section, usually we put the data member, but as you can see here, there is no data member, so that's empty. And then we have one method here, so we have one method. That's why whenever you create the object-oriented programming, you will split into three sections. First is the class name, and then the data member, and then the methods. And when we try to call the object, or we call it create the object, so we need to define the identifier. And we need to call the class. Identifier means a particular variable to indicate the object. For example, I have P1. So this is the person number 1. And I call the class, which is the person. And the person class, at this moment, I don't have any argument. So I just put the parenthesis. This P1 indicates the object number 1 of a person. P2, the object number 2 of a person. P3 is the object number 3 of a person. And if you look at this table here, it is a kind of data. Okay. So the person number 1 is the data in the row number 1. The person number 2 is the data in the row number 2. And the person number 3 is the data in the row number 3, and so on. So if you have another P, for example, this is the person number 4. If you have another person, for example, I want to use another variable, person 5. Is it possible? Yes, it is possible. So you can define this identifier as long as the name is unique, as long as the name does not conflict with the Python syntax. And to call the method, we need to use dot to access the method. For example, P1. So this object P1, I would like to use the method say hi, and the splitter is dot. So using the dot, I would like to call the method, which is the say hi method, and the result will show the argue like this one. So let's see. I have the class. The class name is person, and then I have one method which is say hi, and the print means I'm going to show the output. And if I print the first object, P1, it seems nothing. But actually, the Python create one object, P1. And let's say I have another object or another person, P2. And let's say I have another person, P3. Now, I can try to figure out what is the way to call the method. When I call the method say hi, then it shows how are you. Now, what about if I use the P2? When I use P2, okay, you can just use the dot splitter, and then it automatically shows that we can call the method, which is say hi. So you can just push the tab button, and if you run, the result will be the same. How are you? When you use the P3, also the same. So all objects, or we call this is the data that we have, P1, P2, P3, whenever they call the method say hi, so the result will be the same. How are you? How are you? And how are you? So when we have the class in the OOP, it means this is the primary means of abstraction. Python classes means every data is an instance of a class. So when you have P1, so it is the instance of a class. And we have the methods. It defines the behavior shared by all instances. So we have only one method, let's say hi. So this is the behavior that we can put on the person one. If we have p2 dot say hi, so this is the behavior that we can use for the person two, and so on. And usually we have this kind of class as a blueprint. A class acts as a template for the object. Means whenever you have a class, so I have P1, so I have a person one, and this person one means I have some behavior. I can say something, I can do another thing. Okay, but now we have only one method, which is say hi. And whenever we have the method, we need to understand that every instance should have data or attributes. So the attributes, sometimes we call it fields. Sometimes we call it instance variables. And sometimes we call it data members. So previously I mentioned using data members, but maybe in other books you will see instance variables, or sometimes you can see also the name as fields. Now, when we look into the class, there can be a class with constructor. So when we create a class with constructor, means we want to create an instance of the person using a constructor. In this case, I'm using this underbar init underbar. So this, we call it constructor. And in this constructor, we have one attribute or one data member. So this data is about the person's name. We need to use self. So later we will take a look why we need to use self in this case. And once we set up the person object and we set up the name, we want to define that this is the data member. Let's skip the method say hi. And now we are going to print the same string, how are you? And we will include the person's name. So we need to use self. Okay. Self. Here the data is name and the data type is string. And if you look at this one, maybe at this moment, let's just use plus. Plus means public. So you can access the data whenever you call the data from the object, then you can get the data immediately. The specially named init, the specially named underbar init underbar, which is this one, it serves as the constructor of the class. So the objective is, it is to establish the state of a newly created person object with appropriate instance variables. So I know that if I have 3 person, P1, P2, P3. So how can I know who is P1, who is P2, who is P3? Then one of the way to distinguish P1, P2, and P3 is based on the name. Then this is the data that we can use to see who is P1, who is P2, and who is P3. And we can use constructor to create the person object and the data member. In order to create the data, so we can use one argument. Okay, we call it argument. Before we just use the person and then parenthesis. Now I want to distinguish between P1 and P2. The person 1 or the P1, the name is Berardo. And the person 2, now the name is Yahya. Then if you look at a table like this one, then the person 1, P1, now we have one more attribute, which is the name. Person number 2, it is P2, and the name is Yahya. So to call the method, we still use the dot to indicate the behavior from that class. And we will see the result. How are you including the name? So what is the difference with the first class? The first class, the argument is not available. But now we have an argument and it is automatically embedded into the object. So at this time, now we have the storage to maintain, but previously there is no storage to maintain the argument. We have self. Okay, what is self? In Python, the self identifier plays a key role. So self in Python, it represents the instance of class. And whenever we have the instance variables, every object maintains its own state. So let's say if I use P1, whenever you do with the self, Python will understand every data that you already created for P1, it will belong only on P1. Whenever you have P2, and then when you call self, so Python can understand all data related only to P2. That's why we need to use self for representing the instance of a class. And when we also call the method, self identifies the calling instance. So it will check what is the particular data for P2, what is the particular data of P1, and so on. That's why when we create a data member, we need to define self.name. Self.name. It is a way to save the data, the person name, specifically only in the, for example, P1. When you create P2, then self, it means we are going to save the particular name into that object, P2, and so on. So every object will have their own memory. That's why we need to define self. And for calling the function, we also need to have self. It is to check which object now you are using, which object you are using. In this case, the person object contains one method and one argument. So here, whenever you call a method, you also need to call self. Because whenever we have the self, it refers to this particular object. When you call P1, so it will check what is the memory address of P1. And then it will check what is the name of P1. If you call P2.say hi, then it will check what is the self of P2. And then it will check the name of P2 based on the self memory address. So whenever we call the data member in the method, we call this data member, we need to include self identifier. When we call the data member self.name, self.name. What about this? This is the argument, and the result of this argument will be saved into this data member. So this is the argument. So we will take a look more details with other examples. And this is just a recall. Whenever you have an object, this refers to the name directly calling into the variable name. And we have another argument, this is another name. Then it means this name belongs to P1 and this name belongs to P2. That's why when you call the method say hi, if you call P1, then you will see Bernardo. What about if you call P2? If P1 is Bernardo and if P2 is Park, then you will see P2.say hi. The result will be, how are you? Park. It is based on the name. So now let's see the example. We have a person, we have a constructor, and this is the name of the data member, and this is the name from the argument. And let's see, we have one method, self, and we have the how are you self.name. The person one is Bernardo and the person two is Yahi. If I use P1 dot say hi, then the result is how are you Bernardo. If I use P2, then the result will be how are you Yahya. Now let's make it more complex. Okay. Now I have another object, we call it the student object. And there will be more than one argument. So this is the class diagram. The student object, this is the student class name. So the class is student. The class consists of two arguments in the constructor. So we have student name and student city. There are three data members. Oh, we have two arguments, but we have three data members. 1, 2, and 3. Is it possible? Yes, this is possible. So you don't need to initiate all the data members. You just need some data members for the arguments. In this case, I would like to set up the name and the student city, but for the score, let's just set up from 0. So if I call the student name, it will be saved into the variable or the data member's student name. If I input the student city, it will be saved into the variable student city. And the student score or the variable score will start from 0. So I can see the data members in the class diagram like this one. Okay, you can define the data type later. But as you know, Python has no particular data type at the first time. When you have no data type like this one, can you guess what is the proper data set? We don't know. Okay, sometimes it depends on the person. Maybe if the person wants to define the person's name by number, 1, 2, 3, okay, of course, they can do it. If the persons want to define the student city with numbers, yes, it is also possible because there is no particular data type. Okay, so please be careful with those kind of things. Now, let me just make it simple. We don't need to specify the data type at this moment, but we know that name will be string and city also will be string. Okay, so let's assume that those two are strings. So the variable score will be initialized as 0 when there is no behavior info. So this is 0. And if you look at the method, we have 4 methods. First, get student name. And then there is one argument which is self. Get student CD. We have one argument which is self. Set student score. We have one argument which is self. And another argument which is score. And then you can see the statement self.score equals to score. So whenever I call this method, I want to set a new score. The original score is 0. And if I have a new score, the new score will be saved into the score of that particular object. So the score will be saved into the object. For example, if I have S1, then the score will be only for S1. Get student score. Now I can check what is the score of the particular student. Let's suppose I have S1, and S1 is the instance of student, and previously we know there are 2 arguments: student name, student city. Then I can define 2 data: student name, student city. S2, I have also 2 arguments: student name, student city. Then you can see if it is in the table format, the student one, the student name is P, the student city is Yongin, and the score start from 0. Student 2, the student name is C, and the student city is Seoul, and the score is 0. So this represents this one. Okay. And when we want to access the methods, then we have S1 get student name, we will get P. When you call S2 get student name, you will get C. When you call S1 get student city, you will get Yongin. And when you call the get student city of S2, you will get Seoul. Okay. Now let's check. So this is the class, the student class, and then I have the constructor. Okay. I have already explained this one. And now I have 2 students, S1, which is student B, and Yongin, student C, and so on. If you want to call S1.get student name, then we know that the name is P. If you call the S1.get student city, we know the student city is Yongin. And if you want to know the student score, I want to get the student score, and we know that the score is 0. Okay, the score starts from 0. Now we can have more function or methods. So while accessing the score result 0, you need to set the score if it is required. So by doing the following sequence, the right panel is the result. When you call the student score at the first, it shows 0 because the initial value is 0. And now let's set the score. Let's set the score into 80. And then let's check again the score of the particular student, in this case S1. So I have the get student score. We know that the original score or the initial score is 0. And then now I'm going to set. So what does it mean by set? By the definition, set means it is a function given one argument score. So the data on that object, it will be updated with the new argument. And I need to put an argument which is a number, let's say 80. So I will update the S1 score, originally which is 0, now it becomes 80. That's why when you call S1 and you want to know the current score, now it becomes 80. But what about the S2? When you want to get the student score of S2, it is still 0. Only S1 which is already updated into 80 because we set the new student score. So in many cases, objects can be created in a file. Python file can import other files or objects to execute functions. Objects in a file can be executed by calling the file name. And alternatively, the file can contain main method so that some function will run once the file is called. We just learned how to define the class in the Google Connect. But what about if you have the class in a file? So for example, you have one file. You can create a file, let's say event.py. You know, .py represent the Python file. So we can create the file in the Google Connect. Okay, let's copy and paste this code. And then let's save the file into the event.py. So I will teach you how to create the file in the Google Connect. In the Google Colab, you can input the file. So if you look at the left part section here, there is a kind of document button. Okay. So we can click. Okay. You can click on this document button. So those parts are files related places. You can see in the initial state, all the files are related to the data, because Google Colab is for the data science, for the machine learning. That's why they prepare this data set like the .csv, yeah, for the data science procedure in the Google Colab. Now, I do not want to use this data, but I want to create a new file. So you can do the right click and you can see whether you want to upload, or you want to refresh, or you want to create a new file, or you want to create a new folder. Now, my goal is to create a new file. So create a new file, and let's create the file name auth_event. Then I will create this one, save file. Then you can see it will show you something. Now I will define auth_event.py. So the file already created, but it is an empty file. So you can double click or okay, just double click on it, and then you can see the file on the right section. So this is the file name, auth_event.py. Now let me just copy and paste. Oops. Maybe I need to have another. I need to have a kind of bridge before copy and paste to the Google Colab, because Google Colab has some limitation for paste. So you can open any program, for example, Notepad, Memo Jam, and then put the file here, and then copy from this Notepad into the Google Colab. Then it will be fine. Okay. So you cannot copy and paste directly from the PowerPoint or from PDF, but you need to have one more file or one more tools. In this case, I'm using Notepad. So you can use also Notepad or Memo Jar, and then you can paste on this Notepad, and then after you paste here, copy again, and then you can go to your Google Colab and then paste into this Google Colab environment. Now we have one function like this one. So this is a function, check auth_event. I hope that you already have an idea about Python. If n modulo 2 equal 0. So it means if the input here can be divided by 2, then this is an even number. If it is not possible, or if it is not 0, then it is an odd number. Okay, this is just a simple function. This function actually inside a class, we call it, this is a class or a file, auth_event.py, and now we are going to access this file. So there are two alternatives to access the file. The first alternative, we can use the import and then use this import name to run the code. So for example, here I already give you import auth_event. What is auth_event? This is the file name, auth_event. And then once I call this Python file, I will use this Python file auth_event and call the method. So let me just show you step by step. First, I would like to import auth_event. Okay. After I import it, now I can call the function check auth_event if I have a number which is 2. So 2 can be divided by 2. Yes. Then we will print event. we return even. What about if I want to give you another number? Check odd even 3. 3 can be divided by 2. No. Then the result will be odd. Okay. This is one way to run the external file. The other way to run the external file is the same. You can import the odd event and you can create an object. So let's say the object is O1. Okay. So the object O1, it is from the odd event, which is the Python file that we already import. And then I want to call the function. Okay. So I want to call the function which is check odd event. Once I call the function, now I can just define with O1. Now I can put the argument. The argument means the number that you want to check. The number in this section or n. So if I mention O1 is 2, it means Python can understand this is the object O1 and the argument that I want to check is 2. Or I have another number, let's say O1 is 3. Then Python can understand I want to check whether the 3 is an odd or even. And we will run this section. Okay. Oh. Okay, let's have a break. Okay, I will continue after the break.